in an analytical method transfer, we are going to perform a testing focusing into the most critical ones, the most difficult ones that the receiving unit might have problems. We will not focus into the most, let's say, easier parameters, because they were already validated by the sending unit. This is the concept behind the analytical method. Lastly, important to fully train the analyst before qualifying. This is, again, as I mentioned before, this is for any, of course, for any analytical validation or any validation at all, that you need to fully train the analyst before qualifying them, because sometimes, usually you have deviations in terms of the acceptance criteria of validation linked to a weak or no adequate qualification of personnel, in this case, the analyst. So there must be a policy and procedures to understand and to define how to qualify an analyst. And this includes not only the basic method or SOP reading and training and understanding, but also hands-on training, meaning giving the analysts different challenges, known value samples, etc., and to have a defined process and to verify the efficacy. So it is critical for a successful analytical method transfer, this last topic. So, as we said, the comparative assay is the most widely used. I would say the one used. The same set of tests are performed by both labs. It can be used with validated methods only, as we mentioned. Of course, based on a pre-approved protocol. Pre-approved meaning approved by the sending unit and the receiving unit. Uses an established number of samples from the same lot. The analytical methods must be well-defined, including the acceptance criteria. And the results are compared and checked against this acceptance criteria. In essence, as I mentioned, this comparative assay approach, it represents an abbreviated validation exercise in a way. So this means that the receiving unit, instead of validating the whole method with all the parameters and all the consumed time, they can, based on the sending unit validation, they can perform a shortened or abbreviated validation exercise. This is the concept behind the analytical method transfer. Prerequisites, of course, the analytical method must be validated according to ICH Q2. The scope must be well-defined. Samples, product matrix, equipment. Remember that the product matrix in this case is referred, for example, a product has the active ingredient and has excipients, right? So when we talk about product matrix, we're talking about all these excipients, or it could be, especially in the case of vaccines, it could be stabilizers, it could be adjuvants, all these combination of these compounds associated to the active ingredient, that is what it conforms or defines the product matrix. And this has to be understood because the product matrix may interfere with the analytical method. So this is important to have this in mind. A situation that does not happen when you are testing an active pharmaceutical ingredient, because the API does not have any excipients. So in this sense, it's important in the QC and analytical method world to understand the complexity of the product matrix. And of course, the equipment. It's very important to understand the equipment because, and it's part of the gap. Ideally, the same equipment, same brand. For example, if we're talking about an HPLC, that should be between the sending unit and the receiving unit. That's the best scenario, right? To have the same equipment, same columns, chromatographic columns, even same brand, and same suppliers of reagents. That would be the best situation where we would have the gap near zero. Sometimes that does not happen. We need to identify the gaps, but also try to keep them as little as possible. Okay, so responsibilities of the sending unit in terms of method would be to develop the analytical transfer plan. So actually it's developed by the sending unit. Develop the procedures for the comparative assay. Provide the documents for the comparative assay. Perform and document the comparative assay. Review and approve the test results. They are the originator. And very important, the last bullet, share experience with the method, meaning certain details omitted in the methodology. Again, this is very important, the sharing of knowledge before I even prepare or approve the protocol, and of course, before I perform the actual testing. So in the planning, this share of experience part needs to be fully planned, understood. As we say, sometimes the methods are not completely detailed in terms of certain information. It even could be regarding different vendors or different types of reagents that sometimes is not included in the actual method document. So it's important to have these instances where both teams, sending unit and receiving unit of the QC labs, both QC labs, plan this exchange of information to understand these gaps or these pieces of information which could make a difference when you start actually testing the samples. So in order to avoid lots of time and problems and conflicts, this part of the experience is important. And the reception unit, of course, the equipment qualification for training and assay, they should have all the equipment qualified. The training of their personnel, of course, helped, assisted by the sending unit. Perform and document the comparative assay, and review and approve the test results, as we mentioned. Okay, going back to the WHO TRS, we can find the key task, in this case, analytical method transfer. The documentation provided by the sending unit would be the analytical method specs and validation, included in process quality control. Also, right? Not only, this is important, not only the finished product or finished product quality control, but also any intermediate quality control or in process also. So it's important to cover all the range in this case. And the documentation would be the analytical method transfer protocol and reports as a minimum. Of course, any other pieces of information that could help the sending unit, of course, are applicable. Okay, so in terms of acceptance criteria, and this is taken by, as you can see, analytical chemistry. This is coming from the year 2000, but it's still valid. Of course, ideally, right, in 2 lots with 3 analysts in each lot. So we're testing variability, right? We want to see, and this is also typical from analytical method validation. It's taken from there. So we need to understand how the analysts are qualified. That's why we test the variability of the analysts. And we test also 2 batches. Of course, the system suitability test, that's a requirement. As you can see, the average assay between the labs, this is recommended plus minus 2% inactives, or plus minus 3% in drug products. Again, the concept here is that the variability, the analytical variability in inactive is expected to be less than for the finished drug products, right? In part because of what I just mentioned, right? That the drug product will have a product matrix, right? Remember the excipients and rest, so that affects the method. That's why you have a 3% rather than a 2% for the drug substance or active ingredients. Okay, so this is something to consider. Of course, the known impurities, again, the absolute difference should be less than 0.2%. Unknown impurities, you compare them. Dissolution average, here plus minus 6%. Remember that this information here is not only for vaccines, but it's for any pharmaceutical product. It could be an oral solid dosage form as well. Content uniformity, again, plus minus 5. Okay, linearity may not be a requisite to verify. See, and this is related to what I mentioned some minutes ago, that the tech transfer would, remember, we will concentrate, will focus on the most critical parameters. So in this case, linearity, it's not considered a critical one, and could be waived, could be omitted in terms of the analytical method transfer. Of course, all this, when you omit something or you make a decision, needs to be fully supported by a rationale and, of course, documented, for example, in the protocols. And, for example, limit of detection and quantification must be verified because these are considered critical. Okay, so when you are involved in this analytical method transfer, you could ask these questions, which come basically from experience, right, of colleagues and myself. For example, has there been any known problems with the operation of the analytical method? So you need to understand the OOT, meaning the out of trend, and the OS, the out of specification history, meaning to understand the full report, meaning what happened, which were the causes or the root causes, which was the kappa, which was the corrective actions, if it had a recurrence or not. So the OOT and the OS, very important. For example, and I mentioned this, the type of reagent or brand. Remember, this could be a factor that could complicate the analytical method transfer. So again, this needs to be specified because it might be omitted in the procedures. For example, again, another one, does the receiving unit have developed or have experience and use similar technology in the methods being transferred? Of course, part of the gap, right? Again, if the best scenario would be same equipment, same experience, same quality of qualified personnel, but this is not usually the situation, so you need to understand this. Is it necessary to involve a third-party lab? This is an interesting question. It needs to be defined early in the process. So maybe the sending unit performs the testing, but the receiving unit does not have the capability of doing that, and they need to outsource it. So then you trigger all the GMP requirements in terms of how to select, how to qualify, how to audit, how to monitor, and this should be approved by the sending unit also. So this is important, and it could happen, and it does happen.